Yeah, this meeting will be posted. Graduate students have been suggested, strongly encouraged to attend these live Zoom meetings, but they will be posted on Moodle for them to review, most importantly for their research proposal. For the rest of you who are taking this class as an undergraduate, it will be important for you to comprehend what we're doing today, so that way you can complete the assignment if you choose to do so. I think on Thursday, it will be a day that we will spend working on assignment 2 for people who may have questions about that, especially the graduate students. So I'll send a note about that. But what we'll do today, we'll get into assignment 2. This deals with different types of bivariate tests. Let me see if I can change this. Okay, so the tests that we're going to be talking about today are t-tests, chi-squares, and ANOVAs. And there is entries on all of these types of tests in that SPSS instruction manual book that you were all supposed to get for this class. So if just look those up, specifically for the one-way ANOVA. Okay, so those, the chi-square and the two independent samples t-test, the 2 samples t-test, those procedures are highlighted, demonstrated in that book. And so they're there in addition to what we're going to see here today. And then I mentioned that chapter 14 in Babby talks about a lot of what we already talked about in class on Thursday. And we'll talk a little bit more about what it has in it today in class. And then the next couple chapters just get more into the kind of stuff that we're going to demonstrate in class. And so I'll be reminding people to read those chapters, but yeah, the chapter 14 is one that we've already addressed some of the concepts like discrete and continuous measurement. Those are terms in that chapter 14. So take a look at that, read that when you get a moment to do that. And let's see, let me do something here. Okay, all right, well, let me go ahead and go right into SPSS. And so for many of you, you will have already one exposure to this, either this semester or in a previous semester. And so our task here is to take a look at these tests. Again, for many of you, a second time, but for some of you, it may be a first time doing this, at least with SPSS. But the first thing we're going to take a look at is something called a chi-square test. And when we do this, we are usually interested in looking at differences in proportions, okay? And so when we do this in SPSS, it's really quite simple. Let me go ahead and share my screen with you. Okay, and so this is the AdHealth data set. Now, just to remind people that this is available on Moodle. You just have to download it from the Moodle website onto it somewhere on your computer, and then open up SPSS, open up the file using SPSS by going over to File, Open, and then find that data file. That's the data file symbol wherever it is on your computer, and that's how you can open this thing up. This is back into SPSS. We're on the data, we're on the variable view. Sorry, we're on the variable view. And so we want to take a look at a couple variables to see what the relationship is between these 2 variables. And so previously we were doing what was called univariate analyses, where you look at the characteristics of one variable, the mean, median, the mode, and measures of dispersion. That's univariate statistics. This is bivariate statistics because we were looking at the relation between 2 things. And specifically, when you do a crosstabs, you're usually talking about differences in proportions. And so we're going to look at to see if there's any proportional differences according to the kid's marital status as to who has ever admitted smoking a cigarette. Okay, so we're going to say, you know, are there any is there any risk associated for smoking associated with a particular marital status? That's one way that you could phrase that kind of a question that would lend itself first probably to most simply just a crosstab analysis that we'll do first, and then the chi-square is a statistical analysis of the distribution of the data in the crosstabs. Okay, and so in order to do that, what we want to do is we want to come up to where it says analyze, and let's go ahead and look at both of these variables first, just in their frequency distributions. So let's look at descriptive stats, frequencies, go over here. We're going to do this first, and we're going to see what these variables look like in this regular frequency distribution, so display variable names, and then sort alphabetically. I want to go to PA10. PA10 is where? Did I miss it? Some of these guys, little buggers to find. Okay, it's right there. Okay, PA10, and then we want to have ever smoked a cigarette, and this is just what was asked of most all of them. H1TO1. Oops. Too far up. O1. Okay. Yeah, I'm just wanting to run a frequency table on them. Let me stop sharing this and then go to the output so everybody can see. Right, so everybody at home should be able to see where it says marital status and where it says ever smoked a cigarette. And we're looking at univariate stats for both of these variables. And so that's what it is for each one of these variables, and we can see who is represented in which one of these categories. And the question is, you know, among people who are kids are from divorced families, what percent have smoked a cigarette compared to the kids of married families, what percent have smoked a cigarette? Well, to answer that kind of question, you need a crosstabs. A cross tabulation table is what that's short for. So in order to do that, in order to see these things side by side, so to speak, we want to go analyze, we want to go to where it says descriptive statistics, and we want to go to where it says cross tabs. Okay, once you're inside cross tabs, you'll see boxes that say rows and columns. It does not really matter which variable you put where. But I'm going to go ahead and put marital status in the rows. So I'm going to sort, display variable name, sort alphabetically, and I want to put PA10 in the rows. Like so. And then I want to go ahead and put H1TO1, ever smoked a cigarette, in the columns. And again, it doesn't matter where you put what in this. It will just make the printout look different if you reverse them. Oops. Oh, descriptives, frequencies, crosstabs. Or analyze frequencies, crosstabs. And here we want to put H1TO1 in columns. Okay, so far so good. We've got marital status here, and then smoked a cigarette here in the columns. We want to go over here to where it says statistics. We want to request what's called a chi-square test, and you can read about the chi-square test in your book, but a chi-square test is testing for how different is the distribution of data compared to what we'd expect just at random, okay? And so we want to have that clicked, that chi-square clicked, and then we want to go into where it says cells. And typically what we want to have clicked here is the percentages. We want to have the row percentages, the column percentages, and the total percentages clicked. Okay, so that will report that you'll get that in your output. All right, you go ahead and hit continue. And that's all we need to do so far here. And we go ahead and hit OK. All right. And so what we get here is a printout of a cross-tabulation table that you can read row-wise. So you can say, among people who have never been married, what percent have smoked a cigarette? 49.7%. It can be read column-wise. Among those kids who have smoked a cigarette, what percent are from never married or single homes? That would be 5.7%. And then you can read it as a total. For example, if we want to say, answer question A, how many kids have smoked total? Okay, so here is the yes column for smoking. And so the total number who have said yes to that is 3,080. Okay, so we want to go to all the way down below the total margin and all the way down the bottom of this column, the total number of kids who have smoked a cigarette, 3,080. And then right next to it on the left is the total number who have not. And then this is the total, 5,595 who answered the question at all, because there were some missing. Okay. And so the total number of kids who smoked a cigarette, so you would follow this, you would read this column-wise, because we happen to have cigarettes here in the columns. Here's no, here's yes. And so you read this going all the way down. The total number of smoked a cigarette is 3,080. What percent is that have smoked a cigarette? 55% of the sample has smoked a cigarette. Out of the total sample, that's 55%. So that's right below that in the totals. Okay, and so then the complement, that is 45% have not. Okay, so that's where that 100% comes into. It's just totaling up those two totals. All right. Okay, so that was B. Another way you can look at this, how many kids are from divorced homes? Okay, so divorced is in the rows, right? So it's over here in the rows, and here's the counts. This is the total number of kids that are from divorced homes is over here under 824. So you have divorced kids, the total number of divorced kids, or kids that are from divorced homes, 824. Right here, the 294 is the total number of kids from divorced homes who don't smoke cigarettes, and the total number who do, 533. So over here, the how many kids total, you could say from kids are from divorced homes, 824, because it's over here in the total margins, and we're reading this row-wise, okay? What percent of kids are from divorced homes? And that's 14.7%. Okay, so you're reading the percent here over in the total. You're reading this row-wise for the percent of kids from divorced homes. What percent of kids from single, never married homes have smoked? So the percent of kids from single married homes, so we want to be in the single married home rooms, have smoked. That is 49.7% of them have smoked. Okay. What percent of kids from married homes have smoked? 53%. Okay, so when you're reading this row-wise, you want to look at this first set of percentages that are here. So again, what percentage of kids from single, never married homes have smoked? And that's 49.7%. So 50.3% have not. Okay, so we're reading that row-wise. And then what percent of married kids, what percent of kids from married homes have smoked? 50% versus 47% who have not. Okay. Okay, so G, what percent of smokers are from divorced homes? Okay, so what percent among smokers, so we're looking in the columns, what percent of smokers are from divorced homes? So you want to go to down the column to divorce to the second percent down. So what percentage of smokers are from divorced homes? 17.3%. You're looking at the second set of numbers down. So it's, so see over here it says within ever smoked a cigarette. So you're saying within ever smoked a cigarette is another way of saying among smokers. So you want to look in the yes column, what percent are from divorced, and go down to the divorced row, and it's the second set of percentages down, 17.3%. Okay, that's where that's coming from. So you want to, yeah, you want to have in mind, what are you looking for? A percent out of the total sample, a percent out of the column, or a percent out of the row? Those are the three types of basic questions you can address with just looking at the cross tabs in SPSS, as well as, do you want the percent or do you want the actual count? Okay, so there's that. What percent of non-smokers are from divorced homes? So non-smokers over here, no. What percent are from divorced homes? 11.6%. Okay. And I is unanswerable with this, what percent of the sample contains white smokers. So obviously I did the wrong variable there. I had race inserted there. So you don't have to answer I, so because you can't with this table. But anyway, okay, so that's how you read it. So again, there's total. You can read it as a total. You can read it out of the columns. You can read it out of the rows, or you can read it by the percent or the total, the counts. That is what we're looking at here with this cross tabs table of marital status and smoking cigarettes. Below that is the chi-square test. Okay, so here is the actual chi-square value. Chi-square is a statistic that indicates how different the distribution of data are compared to what we'd expect at random. So chi-square can only be positive. It can be 0 up to positive infinity. Chi-square can never be negative. The bigger the difference between what we observe and what we'd expect at random, the bigger the chi-square value. And so we have a positive chi-square value of 48.53 or so. And then over here we have what's called a two-tailed significance test. Most all statistical tests are usually two-tailed tests, meaning that we're not assuming that our observations are below or above what would be expected at random. We just are expecting that they will be different from what they would be at random. And so that makes it a two-tailed test. And so the two-tailed test, for chi-square, like any two-tailed test, the threshold for statistical significance is 0.05. So if it's any bigger than 0.05, you cannot conclude that your chi-square test was statistically significant. Here we can, though, because the probability of committing a type 1 error is basically 0. It's showing that it's 0, meaning that there really are differences in proportions in the kids who've smoked cigarettes and the kids who have not, according to their marital status. So this stuff is not distributed random. It's different enough from random to say that it's statistically significant. And so the two-tailed test is that indicator of the chance that would be found. It is at random, and it's basically 0. So you can conclude this is a statistically significant chi-square, meaning that there's a significant difference in proportions across in smoking and non-smoking across categories of marital status, right? Okay. So are there any questions on just the mechanics of how you run the chi-square test, how you run the crosstabs? Yeah, so that is a cross-tabulation table. And again, cross-tabulation tables are good when you have like 2 nominal variables like this, or variables that don't have too many levels to them, because you can imagine how hard this table would be to read if you were looking at a variable that was like 5 levels by 5 levels. There would be a lot of cells in there to look at. This is a table that it's a 1, 2, 3, 4, a 5 by 2 table. So, you know, a chi-square table is best for looking at differences in proportions. And so for the homework, you want to look at variables that have few levels to them, or that are nominal variables when you're doing the chi-square example. You don't want to look at variables that have a range from like 0 to 100. That would be more for something later that we're going to get into. But okay, so that's what you use a chi-square for. You're looking at differences in proportions, and they're best used when you have nominal variables, or variables that have very few levels to them, like these 2 variables have few levels to them. One has 2 levels and the other one has 5 levels, so it's a 5 by 2 table. Okay, so the next thing I want to go to is something called an independent samples t-test. And by the way, especially for those of you who in the graduate program who may have not had statistics in a little while, in addition to reading the chapter, there are videos that I posted above each one of these statistical tests from Khan Academy that do a pretty good job of demonstrating the arithmetic that actually goes into solving one of these problems by hand, as well as some graphics to help you understand the concept of what's going on. So suggested that you watch those. But we're going to move on now to t-tests. Now, t-test is a test for differences in means between 2 groups. And so when you have 2 groups that say males and females, or employees from company A, employees from company B, and you want to assess, let's say, their self-reported happiness on a scale of 1 to 10. 10 is just absolutely ecstatic and 1 is absolutely miserable. You would assess that most likely using something called a t-test, an independent samples t-test. It's called independent because the assumption is that the scores on one person's test were not directly influenced by the scores on somebody else's test, at least the tests that are coming from the group that you're testing against. Okay, so a t-test is used when you're looking at these differences in means or averages between groups. Okay, so in the example that I have on Moodle, we're going to test for gender difference in delinquency. And I think all of you probably can imagine which way this is going to go. If you had to put money down on it, you'd probably guess that boys are going to turn out to be more delinquent than girls, and you most likely would be right. And so, you know, with all the data going into this, one could say, well, we expect that that boys are going to be more delinquent than girls. The question is just how much. Well, if that's the case, then you really could just be justified in doing just a one-tailed test. If you do just a one-tailed test, it's easier to find statistical significance. It's about half as hard, in fact. However, the typical thing for people to do, and the default in all your SPSS programs, so you don't have to worry about this, you don't have to tinker with anything, will be a two-tailed test, meaning that you can't assume that the means for boys will be higher than girls or lower than girls. You just are assuming with the research hypothesis that gender will have some effect on delinquency. So in this analysis, in the t-test analysis, the group you belong to is considered the independent variable having effect on the dependent variable. In this case, it's delinquency. And so we're just saying with the hypothesis that's being tested here is that gender will have an effect on the mean of delinquency, whereas the null hypothesis would be that there would be no gender differences in delinquency either way. Okay, and so that's why it always goes back to just a two-tailed test, and that comes from the normal distribution, the probability of being in one or either tail. Okay, so we want to take a look at this. First, what we want to do is we want to return to something that we were doing in the previous class, and that is to create a variable. And so what we can do is we need to create a delinquency variable, and so we can do this by going to transform and then compute, and then you want to grab all the delinquency items, which I'll do this quickly, as quick as I can. Just calling this delinquency, as we do when we're making a new variable here. We're not necessarily calling it delinquency, but you have to call it something. And it's H1 DS1 through 15. I'll sort alphabetically. Actually, I'm just going to do this the fast way. People at home may not be able to see me do this, but let me go so they can see what I'm doing. I am looking for all the variables that make up that. I'm going to go down to H1 DS1, and I'm going to just cut and paste. So I'm going to, or at least copy and paste. Copying H1 DS1 through H1 DS15. So these are all the items that reference delinquent behavior. Okay, so I'm copying that, and I want to go ahead and paste those in there. And again, there may be still a shorter way of doing this, but I'm just putting parentheses around the first one and commas after each one of these variables. What we're doing, we're summing the totals of all of these. We're putting a comma after each one of the variables except for the last one, which will end with a parentheses. Okay, so we're summing delinquency. We're making a delinquency scale by summing all the individual delinquency items. Okay, we're going to go ahead and oops, I'm sorry, I forgot to type the word sum in front of here. Now just go ahead and type the word sum. I don't think it needs to be capitalized, but type the word sum in front of it, and it'll go ahead and sum it up for you. All right. So, all right, so yeah, it's just showing the syntax here of creating the delinquency scale. And now what we want to do, we want to ask the question, well, are there average differences between boys and girls in delinquency? That would be a question you could answer with a t-test. So whenever there's just two groups and you want to know differences in averages on some outcome, you can use an independent samples t-test. So we do that by going over to where it says analyze and go down to where it says compare means. Because that's what we're doing. We're comparing means, the means of girls and the means of boys. So there are multiple t-tests here. I want you to go down to where it says independent samples t-test. There is something called a one samples t-test. That's just testing to see if you're different from the hypothetical population average. it's not too useful of a test. There's also something called a paired samples t-test. That's a before and after test. Did this group change after they are exposed to a stimulus or not, before and after? But we're not doing a before and after thing. We're doing two groups. So it's an independent samples t-test is what you want to be on. So you go into the independent samples t-test. All right. So in the independent samples t-test, you will have this screen. Now, the grouping variable is where the independent variable is supposed to go. They call it, for whatever reason, in SPSS, the grouping variable. So in this case, we want our grouping variable, our independent variable, to be biological sex, okay? And just to show you real quick, the people that are not immediately familiar with this, is that we want to, I'm going to show you how biological sex is coded, because this is important for the grouping variable. When we put that into SPSS for analysis, we want to be straight on how males and females are coded. And so if we come over here, I'm in variable view. I'm looking at biological sex, and I come over here to values, and I click on this, and I can see males are coded as 1 and females are coded as 2. And so we need to put those values of 1 and 2 into where we have the grouping entry. Okay, so we go back to this, and so we want to say, okay, our grouping variable is going to be biosex. It's going to be it's right here. I don't even have to. I'll just go ahead and do sort alphabetically so you can see, or by variable name. Okay, yeah, here's the variable, and we're putting it over there. You don't have to change that, by the way. It doesn't matter. It's easier for me to do that. And then we want to go, when it's over there, define group C. It says question mark. Okay, what are your groups? What are the two groups within that variable that you want to compare? Well, there's only two. There's males and females. So we're going to compare group 1 to group 2. Okay, and so you can do this with other variables that have more than 2 levels to them, but you just have to specify using a t-test what 2 groups you want to compare to one another. So you could use the marital status variable to compare divorced and separated people to one another if you wanted to. But here we're using a t-test with gender as the independent or grouping variable. We hit continue. And then the test variable is the dependent variable for the t-test box. That's going to be delinquency. Okay, so we want to go ahead and put our delinquency variable over there. And delinquency, by the way, if you click back to file order, whatever variables that you made will appear. This is from a previous file. Let me see, sort alphabetically. They should appear at the very end. Not sure. Oh, wait, here we go. Because I already put it over there. Anyway, but it would be, yeah, if it were, the delinquency will appear at the very end if you have it sorted on file order. The last variable you make will always appear at the end of the list if it's sorted on file order. Okay, so let me put that back over there. For the independent samples t-test, this is all you have to do. There's no other options or anything else you need to set up. Okay, so again, we're looking to see if there's a difference in means between boys and girls on the outcome delinquency, the dependent variable delinquency. So we hit OK. Okay. And what we have here are group statistics, it says. Okay, so here are the males, here are the females. Here is the average for males, the mean for males. Here's the average for females. Here's their standard deviations. Standard error is something that's based on the population estimate for the standard deviation in the population, but that's not terribly important right now. But here are the 2 main stats of central tendency, or central tendency and dispersion for males and females for delinquency. So the question is that a significant mean difference? Okay, well, to answer that question, because we can eyeball it, we can clearly see, yes, boys are more delinquent according to their raw scores than girls. But there's individual variation, and so we don't know if the individual variation exceeds the group variation. Because on average, the differences may be there, but there may be some really delinquent girls, so much so that it kind of washes out the higher average delinquency of boys. And so that's why we need to do this t-test. We need to know over and above all the variability, because it's not like all girls are equally delinquent and all boys are equally delinquent. There's a lot of variability among boys and girls. So over and above that variation among boys and girls, is there an overall average difference or group difference? Okay, so there is a couple things that we need to focus on down here in the t-test results. The first is something actually called an f-test. So an f-test in this case is being used. F-tests are used in different instances in statistics, but in this case you see an f-test. The f-test there is being used to test whether or not we can assume that the variances are equal in the population according to the sample data, or assume that they're not equal. Now, the null hypothesis is that the variances are equal. So if you have a statistically significant f-test, then you cannot say that the variances and the populations are equal, which has consequences for which t-test you look at. Okay, so this f-test is an f-test of 186.35 something, and this is a two-tailed significance test. And just like any other statistical significance test, the cutoff for statistical significance is 0.05. That is anything above 0.05 is considered not statistically significant, but this is below that, this is 0. So we cannot assume that the variances in the population for boys and girls delinquency is equal. We have to assume that we can't assume it's equal. We have to assume that it's not equal. When that's the case, when F is significant, that means we have to look at the second t-test down, because notice there are two values under where it says t. So if F is significant, which it is here, we look at the second t down. Now, in many instances, it won't matter. T will be very similar to one another, regardless of whether the F is significant or not. But what you see here is a significant F. So we look at the second t-test down, and we see what it is. We see it's 11.563. And so we say that's the value for the t-test. Okay, is it significant? Yeah, it's highly significant, and the p-value is 0.000, and so that is definitely smaller than 0.05. And so we can conclude then that there is a statistically significant difference in average delinquency scores between boys and girls. Boys, on average, are more delinquent than girls. All right. So, and then there is some other statistics here of some value here for more detailed purposes, but that is a t-test, and a t-test again is good for testing for differences in averages between two groups. All right. So when we have a situation though where we have more than two groups, when we have multiple groups, we will need to do something other than a t-test. What we need to do is something called an ANOVA. An ANOVA is an analysis of variance. So if you have more, the number of groups that you are testing for mean differences exceeds 2. So you have 3, 4, 5, 6, 7, 100 groups, whatever it is, that is something that you want to use an ANOVA or analysis of variance. A one-way ANOVA is the name of that test. And so if you have people from this marital status, that marital status, and that marital status, divorced, never married, and married. That's 3 groups. So you'd want to test for average differences using an ANOVA. Repeating t-test using the same groups, just alternating out comparisons, increases the odds of committing a type 1 error. So to avoid that statistically, what we do is we do an ANOVA. And so for ANOVAs, again, they are doing something similar that a t-test is doing. It's kind of an expansion of a t-test. You're looking at the variation within and between more than 2 groups, and then comparing, testing to see is, you're saying, okay, overall, we know that people from these 3 different groups have different averages. They individually have different scores. So over and above the individual differences within these groups are the overall averages between these 3 groups different, or 4 groups or 5 groups. And so that's an ANOVA. All right. So with ANOVA, what we want to do is for this one, we want to take a look at marital status will be our independent variable in this case. And so with ANOVA, the idea is that you have more than 2 groups. So in marital status, we'll have 5 groups, but it's still like t-test. The assumption is that your membership in a particular marital status has an independent influence or impact on the outcome. In this case, I'm using the picture vocabulary test. It's a type of verbal IQ test that was given to all the respondents, all the child or the student respondents who completed the Ad Health survey. And so we're looking to see if there are any differences in average scores across marital status group. And for that, you would want to use an ANOVA, not a chi-square, because in the case of the picture vocabulary test, the scores range quite broadly. So let me first show you that. This picture vocabulary test, we already looked at marital status. So I want to put that back. We're putting smoking back. And I want to look at this variable AH_PVT. That's the picture vocabulary test. And yeah, should be at the very top. Yeah, not the raw one, the PVT, that one. Okay, and we go ahead and we can just run a frequency on that. Recall that this is the place where you request your central tendency measures, your mean, median, mode, your standard deviation, your minimum, maximum. And we could just do that for the heck of it for practice. And okay, so I'm selecting all of those items, and then we're just taking a look at this. So yeah, this is the Ad Health picture vocabulary test. The average is about 100, and that's what IQ tests are designed, so that the average will be about a 100. And then there's the median, here's the mode, and then the scores range all the way down from 14 up to 139. And so this is something clearly you would want to run a chi-square test with, because you'd have, look how many levels there are to this. That wouldn't make any sense. This is something you would want to use in ANOVA, because in this case, we're looking to see if there are differences in test scores across more than 2 groups. And so if it were just 2, if it was just boys and girls, you could use a t-test, but that's not our case here. We have a situation where we're asked to look at marital status, or relationship between marital status in this outcome, scores on the picture vocabulary test. All right, so in order to do that, we want to go into where it says analyze and go to where it says, again, compare means. But in this case, we're going to go all the way down to the bottom where it says one-way ANOVA. Okay, so a one-way analysis of variance. Okay, so the dependent list. We just have our one dependent variable, and that's going to be the picture vocabulary test. And so what we want to do is it's all the way, see at the bottom here, yeah, Ad Health picture vocabulary test, AH_PVT. I didn't sort there by variable or alphabetical order. I just went down to the bottom because it's one of the variables at the very bottom. And then we want to go into factor. Now, factor is where you put the independent variable in the ANOVA model. So in this case, it's going to be marital status. And so let me display variable names, sort alphabetically. Okay, PA10, marital status. Where are we? We want to put that in. Okay. So yeah, so this is the dependent variable is the scores on picture vocabulary test. The independent variable here, the thing that's assuming to have an influence on this dependent variable, is the marital status. Okay, and so we're essentially going to be testing for differences in verbal IQ across marital statuses. And what we want to also do here is we want to go into where it says post hoc. I'm going to go into that. We want to click what's called the least squared difference test, the LSD test. So what this is a test that's going to look at what particular groups have differences in test scores. Initially, we'll be shown whether or not there are any differences in averages across marital status groups. Then the next question is, okay, if there are differences, where do the differences lie? Are they between married people and everybody else? Are they, you know, where are the differences? And so there are lots of different ways to request, or lots of different tests to look for differences in averages between particular groups. The one that is most likely to come up with positive hits, a positive result, that is significant differences, is the LSD test. It's the one that's least restrictive, and so that's the one we're going to go ahead and use. So we can find something. So we'll click that, but there's a bunch of other ones. This is the most the most liberal, I would say. And then the Dunnett seats that is the most conservative. That's the one that's most restrictive. But we'll stick with this one for simplicity's sake. LSD test. Go. Okay. Continue. And then options. Let's go into options, and let's go ahead and also get click your descriptive statistics. So that's going to print out for us the vocabulary test scores for each one of those marital status groups. So we click descriptive statistics. You don't have to do it, but it's something that's very nice. For the purposes of this assignment, yeah, you want to do that because it'll give you the output right along with the output for the ANOVA without going into descriptive statistics and frequencies and doing it separately. And I think that's it. Yeah, I think we're good there. Let's just go ahead and go with that, and we'll go ahead and hit OK. All right, and so so you get several pieces of output here. The first thing that you get are descriptive statistics showing the vocabulary test scores for each one of these marital groups. And so we can just eyeball it. We can see the overall average is 101. The highest, though, is kids from married families. The lowest is kids from single or never married. And then everybody else is kind of in between. And so you can look at it and answer those first couple of questions. Which marital status has the highest average test score? That's the kids from married families. Which marital status has the lowest average test score? That would be the kids from single, never married families. Are there statistically significant differences between marital statuses and average test scores? How can you tell? Well, the first thing we want to do after looking at this descriptives table, showing us what the averages are, is go down to where it says ANOVA here. And here again is another F test. Okay, so what this F test is doing, it's testing to see if there are any differences in average test scores across marital groups.
any at all, by any comparison whatsoever, are there any differences whatsoever? Is there, to any extent, it's overall what it's testing is the extent to which differences in averages between these groups exceed the differences in individuals within these groups, because it's not as if every kid from a married home has the same verbal IQ score. They vary, and so to the extent that there is average differences that exceed the amount of variation produced by individual differences within these groups, that's when you start getting a positive F score, or F score that's north of 0. If the differences are about the same between and within groups, the F score will be 1. It'll be non-significant. But this F score is 61. It's positive. It's statistically significant. Again, this is a two-tailed test, and so like any two-tailed test, the cutoff for statistical significance is 0.05. So this is smaller than 0.05. So you can conclude, yes, there are statistically significant differences between marital statuses in average test scores because of the statistically significant F. All right, so that is what F is telling us. Is there any differences overall, sort of a global assessment overall? Are there any differences? Does the average in verbal IQ, is the overall average, does it vary at all if you go from one marital status to the next? And it says, yeah, it does, beyond what we'd expect just by chance. All right, so when we come down to this next bigger table where it says multiple comparisons, this is our post hoc test. This is that LSD test that's looking to see, okay, where are the differences exactly? Where do they lie? And so when we look over here, we see over here on the left-hand side, it says single, never married. It is comparing single, never married to married, widowed, divorced, and separated. Okay, and so what it's doing, it's saying, how does the single or never married compare to the married in terms of the average picture vocabulary score? Well, they score on average about 10.392 points lower, and that is a statistically significant difference. You can tell that, one, there is a star there. It actually puts an asterisk next to it to indicate if it's significant, at least at the 0.05 level. And then over here, again, another significant two-tailed test. Okay. So yes, there are statistically significant differences between single, never married, and married kids from married homes in terms of their picture vocabulary tests. The kids from married homes are scoring significantly higher on average. And you have to say that on average, because it's not like every individual who's from a married home is scoring higher than every single individual that's from a never married home. That's not true. What is true, though, is there's differences in the averages, and which in and of itself is meaningful, because that suggests there's something about being from a single married home which does not impart optimal skills for taking things like picture vocabulary tests as compared to kids from married homes. And so you see that difference. Okay, so we're looking here at single, never married compared to widowed. There is a difference again. That the single, never married, about 4.7 points lower in their test scores, but that's still significantly different. Comparing to divorced, 7.95, 2 points lower than divorced, and that's significant. Now, interestingly, we go to separated. They're also lower than separated. Their scores are lower on average than when compared to separated. That's the actual mean difference, 2.025 points. However, it is not a statistically significant difference. See, look, the p-value here is 0.082. So that's higher, that's greater than 0.05. And so we would have to conclude, while there are differences in the averages, they are not statistically significant differences in the averages. That is, that there is too much, there's too great of a chance that if we would redo this sample again, the averages would be even closer between the never married and the separated than what they are now. And so there's too much variability within these groups that overlap with one another to say that that 2-point difference is a statistically significant difference. Because it's greater than a 5% chance. It's an 8% chance out of 100 that if you were to redo this again, you would find that you get something that's off, that's different, that's not within the same range as what you're finding here. So that's not significantly different, but it is, and you can also tell that again, just kind of cheating here, just looking at, it doesn't have an asterisk, it's not starring it for you. So you can look up and down this column of numbers real quickly and see where the differences are and where they're not by just looking at the asterisks, but it's, yeah, it's not different. Okay, and so this is just doing the same process, but over again. It's comparing now married to everybody else, and it's showing that, yeah, married is significantly higher than every group, higher than single, never married. Scores are higher than widowed. Scores are higher than divorced. Scores are higher than separated too. So they, across the board, kids from married homes are doing better on average on their picture vocabulary test than kids from any other family structure, any other marital status. Because it's showing here, it's that this is a 10-point difference in the favor of married, 5-point difference in the favor of married, 2.4-point difference. It's showing right here mean difference. That's what it's showing there in these, for what these numbers are, that it's actually the one mean subtracted from the other. Okay, and over here, these are all your significance tests. And again, these are two-tailed tests. And the typical cutoff for a two-tailed test is 0.05. Anything above that is considered not statistically significant. All right, folks, so the homework then, if we want to just take a look at that. Yeah. So I'm asking you to conduct 5 statistical tests examining parent-child relationships in the AdHealth data. Must include a chi-square test, a t-test, and a ANOVA. So in the AdHealth data, any of those variables that start with PA, like in the section that starts with PA1 all the way through PA whatever, like PA10, for example, was marital status. Those were all asked of, those are questions that were asked of the parents. So anything in there. Also, you might want to just consult the website, and you can just quickly come up with all the, you can find all the parental items from the website. You can search the website. There's a really useful tool on the website that allows you to find variables really quickly. And then you want to look at the relationship between some parenting variables, like we did today, and some kid outcome. It's up to you what you want to look at. I just want you to use the correct statistical test. So this is to see if you are understanding this right, because there's some tests that are right for some variables and some tests that are right for other variables. So you must include, you have to do 5 tests overall, but you have to include a chi-square test, a t-test, and an ANOVA. So one of those you can do more than once. If you completed assignment 1, use variables from your table. Paste the SPSS output for each of your tests onto your assignment. So you just right-click, cut and paste directly from the SPS output and paste it right into the Word document. For each test, report on the results as we did in the class exercises. So yeah, in the class exercises, we reported on several examples from a crosstabs table. So you want to answer questions from your crosstabs table that are equivalent to that. Just make up your own questions and answer them. And I want you to then follow the same model, though, for the t-test and the ANOVA. Make up your own equivalent questions and then answer them for the assignment. And so we will, what we'll do then on Thursday is I will leave it open to people to work on this independently on Thursday. I will put a Zoom meeting out. It will be optional if you want to do that. For graduate students especially, I would encourage you to work on this with me on Thursday during our class time. I'm going to have to contact the graduate students anyway about separate Zoom meetings that deal with their research proposal. But anyway, yeah, this Thursday, what we'll do is we'll have that time reserved to make sure that everybody knows what they're doing with assignment 2. That's not due until Monday, but we will have that time reserved on Thursday. And so Thursday will be optional, but if you don't understand what to do on it, you will want to, if you're an undergraduate, you will want to know it for the exam, and if you're a graduate student, you'll need to know it for your paper, for your research proposal, because you'll need to demonstrate it in the paper. So any questions? If there are no questions, you are free to go. But yeah, Nick. Yeah, I'll be in here Thursday. I'll be in the lab Thursday, and so that will be, and we'll do it the same way, but it'll be optional. We'll just be focusing on assignment 2. Okay, so that is all for today, folks. If there are any other questions, I will be happy to hang out here and address them. If you have questions about the first assignment, I can address that, but the second assignment is due not until the 16th, and so we will spend Thursday giving people a little bit of time to get caught up, just make sure everybody is on board here with what we're doing, and then we will move on to the next phase of this data analysis section of the class. So, okay, folks, that is all. Unless you have something else, you are free to go. Take care.
I have one question. Sorry.
Hi.
So when you say child relationships, that could be like any of, so like I understand like the parent has to be like PA, but then when it says child relationship, which one of those would I use?
So anything that comes from the parent section, and then anything that comes from the kids section. And so we did, for example, we did marital status and their scores on the picture vocabulary test. That's an example of parent-child relationship. So it's something that the parent, it's like their status or something they're doing, and then something that is being reported on by the kid.
Are there specific like lettering for the kid, like how there's PA for the parent?
The whole survey, almost the entire survey is addressed to the kid. The first,
Okay.
it's the items that start with PA. That's when you get into parent questions. You can also look at the website, and that'll show you, and there's the code book on there as well that you can just, you can search for that and find out real quick what part is what. But yeah, anything that says PA, that's from the parent survey. So just know that for when looking for parent stuff.
Okay, and last question, can you explain, well, obviously it's a lot to explain, but explain what the chi, however you pronounce it, that square test? Because I didn't understand what the difference was between that one.
Okay, yeah, the chi-square test is a test for differences in proportions when you're doing a crosstabs table. So you want to select that under the statistics box when you're running a crosstabs table. So when you're going to go into crosstabs, you want to click on statistics when you're putting what you want in your rows and in your columns. And then you want to click on chi-square. What a chi-square test is telling you, and the chi-square will always be something north of 0. It's telling you how different the observed distribution of data is compared to what you would expect at random. And so the more positive the chi-square value, the more significant it is. And so if you have a statistically significant chi-square, that means that you have a statistically significant difference in proportions. So like when we did the smoking exercise, the one with the smoking, it showed that there was a statistically significant difference in proportions of kids who smoked according to the marital status. Yeah.
Okay. All right. Thank you so much.
You're welcome. Yeah.
I think our baseball's first game is Thursday. We have like a doubleheader.
Uh-huh.
So I'm not sure on what time we'll be leaving. I know it's away, so it might be like early in the morning.
Is it this Thursday?
Yeah.
Yeah, because class is optional, you know, so it'll be posted online. So if you can't make it, it's okay because it's optional anyway. But yeah, we'll just be doing assignment 2.
All right. Yeah, I wish I would be here for that.
But well, All right. Well, good luck with your game. At least you have good weather.
Yeah,
It's finally thawing a little bit. God.
There's no snow in the field still.
Yeah. Well, that's.
I don't know if I like downloaded this wrong and it won't like let me use it. But
Oh, okay.
so when I sign in, like it asks me like if I want to open apps anywhere. So I click on that. And it says validation successful, but the SPSS is under unavailable.
Is that a Mac that you're using?
Yeah.
It doesn't work on Mac.
Okay, so do I have to do it on one of the computers?
Yeah.
here?
Yeah,
Okay.
sorry. Yeah, it doesn't work on Mac. I sent an email about that a little while ago. You can get a SPSS version on your Mac. You can rent it for like $39. But if you can avoid doing that, I would. I mean,
Okay.
but yeah, that's the deal with it's not available on
I
on
might
Mac.
just rent it because I feel like these computers sometimes in the library are like so slow.
Oh, I know. Yeah,
So-
it takes a good 7 minutes for this to get
Yeah.
started. It's always like, come on, come on.
Thank you.
Oh, you're welcome. Take care.